Is that in your prelim papers, in any full set paper, paper 1, paper 2, we are expecting each paper to be out of 150 marks. And I think your teachers would have given you a document called exam guidelines, which basically gives you information about, or they would have listed the topics that will be covered in paper 1 and also topics that will be covered in paper 2. So your paper 1 will be out of 150 marks and your paper 2 will be out of 150 marks. Now, the expectation based on the format and the information that teachers know and the pattern of exams, we are expecting investigations to cover plus minus 20 marks per paper. So if you are able to take in a few things from this lesson, you should be able to be getting around 20 marks from the paper before you even understand the content. So that's why I'm saying this is very important. And this is for both the prelim exams and also the final exams. So we're going to start. Please feel free to ask me a question anytime. This document, I've made it available for my students. If you want it, you will just let me know. We normally sell these documents. They are free to the students who are part of the tutorial groups, but I'll think about it if I'll just send it to you guys for free. All right, we'll start with the first thing. Now, what I'm going to cover here, guys, is theory and application. So no one is going to ask you what a scientific method is, what is a variable, how is an independent variable different from a dependent variable. No one is going to ask you that. I am explaining these concepts so that you can then use my explanations and then apply them into investigations. We're going to be able to do that together. Okay, so the first thing that we're going to look at is a scientific method. The investigation that you get in your question paper is an investigation that would have in a way followed a certain method, because an investigation starts with a question, right? And I normally use basic questions when I teach this. I start by mentioning something about a plant, right? So you notice that there is a plant at home that keeps on growing. And you have no idea why that plant is growing. You don't know what's causing it to grow. And you don't know maybe other information. Let's say you don't know photosynthesis. And then you start asking yourself questions. Why is this plant growing? You can see that it's growing because of a change in height. And then you ask yourself, what could be some of the things that would lead to this plant growing? Those are the questions, right? And then a scientist will then start conducting an investigation in order to find out the answers. The answers to what? What's causing the plant to grow? How are we able to see that the plant is growing, right? Or what are the things that are needed for certain processes in a plant to take place for it to grow? Now, the scientist, will then conduct the investigation following a series of steps, which are then called what? The scientific method. Now, the reason we have a universal scientific method is that if your investigation is read by someone in Japan or someone in Zanzibar or someone in Ghana, they should be able to follow through how you did the investigation and how you were able to arrive to a conclusion. Right. Now, in grade 12, you are not going to be asked to conduct an investigation. You will be given one. Now, this is where the investigation skills come in, because you are not doing the investigation. You should be able to be in a position to read and understand the investigation. Actually, this scientist, what were they investigating? What were they trying to find out? What are the results? What were the variables? So you yourself were not part of the investigation, but when you analyze it, you need to be able to internalize it so that you can feel like you were part of it. So I've analyzed the first thing. I said, one, they would identify the problem. Now, the problem might be mentioned in the exam question, but most of the time it's not mentioned. Okay. Then this is important. The ones that I'm making a note of, that's what I want you to write on your side. You make a star and say aim. The aim of the investigation will be given to you. I am 100% sure about this. Any investigation that you are going to be asked to analyze or asked questions on, it will be given to you. Now, they can make it obvious. Sometimes they won't make it obvious, but most of the time, because they're realizing that students are failing investigations these days, they're making the aim obvious. Now, how are you going to know the aim and what is it, right? An aim of the investigation is the main purpose or reason for doing the experiment. So if, for example, I'm saying, oh, I'm noticing that the plant is growing. I want to find out what's making my plant to grow. That is my aim. So my aim, for example, could be to determine, I want to be able to determine the effect, maybe because I can see that this plant is placed next to the windowsill and is receiving sunlight. I want to be able to determine if sunlight is the one that is causing my plant to grow. That is the aim of the investigation, to determine. So if there's a lot of people that have joined and I've connected quite a few devices, yeah, it's quite a lot. It's going to be a bit slow, but please listen to what I'm saying more than looking at what I'm reading. So my aim of the investigation to determine if light is needed for plant growth. Now, that is my aim, right? To determine if light is needed for plant growth. Any investigation that will be given to you will have an aim, and you're going to see that once we start doing the examples, right? Now, this is the statement, and this is what my investigation is about. I want to find out if light, not even lamp light, the light from radiant energy, the light from the sun, is the one that is causing my plant to grow, right? That is my aim. The aim will be mentioned in the investigation. They'll say researchers investigated the effect of, right? The effect of light on plant growth. I can even phrase it like that, to determine the effect of light on plant growth. So it depends on how they phrase it. But once they phrase it with the effect of, they have given it to you. That is your aim. Okay, so your aim is going to inform you what has been tested, what has been measured, and what has been observed. Now, before we move, I'm going to rewrite it here so that I can start asking questions. So be ready to unmute. Okay. To determine, let me say to determine the effect of light on plant growth. That is the aim. I'm going to mention these two factors that I feel like most of us confuse. From your aim, you are able to get two factors. Which factors are those? The independent variable and the dependent variable. They will always be found in an aim, nowhere else. Sometimes, if you're lucky, they mention them in the aim and you're able to also find them in the table that will be given to you. Maybe the table of results or the table of the data that has been recorded. But from the aim, you are able to get these variables. And I'm telling you, all 39 people that have attended, I need you at the end of the lesson to be the master of finding variables. You cannot confuse them. How? The investigation here, it says to determine the effect of. Now, when we speak about the independent variable, we are speaking about the factor that we are investigating, right? And this factor, we are able to change it. We are able to change it in so many different ways, and it will be determined or mentioned in the investigation. So in this case, we are saying to determine the effect of. Whatever that has been written after the word of, that is your independent variable, because that's what I want to investigate. I want to investigate the effect of light, right? So light then becomes your independent variable. This is easy. But now, when we speak about the dependent variable, if someone is dependent, they are relying on someone else. So teenagers are dependent on their parents, okay? So if the parent has 100 Rand, that means the teenager will be able to buy 5 sweets, right? So whether the teenager is able to buy sweets or not, it is dependent on the parent having money or not. So the parent then becomes our independent variable in everyday basic examples. Please do not go into an exam and write a parent and a teenager and say this teacher online said this. Ha! I never said that. I'm just making an example, right? So if the parent is able to have 100 Rand a month, and then be like, okay, this 100 Rand is allocated to the purchase of sweets. Now, the teenager or the learner will then be able to buy 5 sweets. But if the mom then says, okay, in September, I do not have money, the teenager, remember, is dependent on the parent. So that means the teenager won't be able to buy sweets. So whether the teenager is the dependent variable, is able to buy sweets or not, is all dependent on whether the parent has money or not. If the parent has money, the teenager will be able to buy sweets. If the parent doesn't have money, the teenager won't be able to buy sweets. You are not going to get a simple investigation like that in your exam, though. Let's come back to mine, right? To determine the effect of light on what exactly? On plant growth. Plant growth then becomes our dependent variable, because whether the plant manages to grow or not, me and you know about photosynthesis, right? So whether the plant is able to grow or not is dependent on the availability of light. If light is available, the plant will be able to grow. If light is not available or if light is not present, the plant will not be able to grow. So whether it grows or not in this particular investigation, it is dependent on the availability or absence of light. If your aim is given as simple as this, the effect of, the factor after the word off is your independent variable. And then the factor after the word on, because I'm trying to investigate the effect of this big thing factor on that. If light is available, what does it do to the plant growth? If light is not available, what is the effect of that on the plant growth? So I want us to be able to understand the two. What I also need to mention is that the factors are not necessarily always just one-word factors. You need to read into the investigation and understand it. And unfortunately, if you are one of those people that are taught investigations now in grade 12, it does take a little bit of time to understand everything. At my school, we teach these things from grade 8 and we mark them according to metric standard. So by the time the learners get to grade 10, they know exactly what to do. Now, I want us to do this one together. So that someone can tell me what the variables are. This is an aim. The aim in the next example, it says to determine the effect of temperature on dissolving sugar. There is a part where you can raise a hand. There's a hand and it says raise. So if you are ready to give me the variables, please just raise your hand and then I'll note you. I need the independent variable and the dependent variable. Litabo, I'm listening. Please unmute.
The independent variable is temperature, and the dependent variable is dissolving sugar.
100%. Thank you. 100%. The dependent variable here will be the dissolving sugar, and the independent variable is the temperature, because whether sugar dissolves or the rate at which sugar is going to dissolve is dependent on the temperature. Sugar will dissolve whether there is cold water or hot water, but it could be the rate of, depending on how they phrase the aim or the investigation. So this is very, 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 very important, right? I'm going to write the last one and then we move. So I'm going to say the effect to determine. So if you are ready to answer, just raise your hand. I'll note you to determine the effect of light intensity. Light intensity on the rate of photosynthesis. Hands up, hands up, hands up in the air. I need someone to tell me the variables. I need someone else's hand to be up.
Good evening,
Guys. Yes, I'm listening.
Good evening, ma'am. It's Lily. Good evening. The light intensity is the independent variable, and the rate of photosynthesis is dependent variable.
100%. Independent variable is the light intensity, rate of photosynthesis, not just photosynthesis. Lovely. Thank you so much for that. Rate of photosynthesis is the dependent variable. I was very intentional about writing this aim because I wanted to make sure that we understand the factor in question. The independent variable is not just light, it is the intensity of light. It's that whole thing, intensity of light, right? And then the dependent variable is the rate of photosynthesis, not just photosynthesis, not just rate. So I feel like by now we are understanding exactly how to get the variables. You cannot swap them around. After this lesson, you cannot get them wrong in any exam that you are given. Now, because what here? Whether photosynthesis takes place at a higher rate or a lower rate is depending on the intensity of light. And what we know is the relationship is higher light intensity increases the rate of photosynthesis. So that would be the relationship. I'll still speak about relationships. I'm moving when it comes to variables. I will speak about controlled variables. Let me just speak about them now so that I don't have to speak about them later. So remember, when it comes to variables, you've got three. You've got your independent variable, right? Which we say you get from the aim. And then you have your dependent variable, which we also say you get from the aim, right? So these two you get from the aim. And then you have your controlled variables. These controlled variables, when I start projecting the exam questions, you get your controlled variables from how they tell you the investigation was conducted. So there's normally a paragraph in your investigation question that will say the procedure was as follows. And then they tell you exactly how they did the investigation. Now, what are we exactly looking for there? In that section where they are speaking about the procedure, we are looking at factors that were kept the same or factors that were kept equal. That's what we are looking for. They will 100% ask you about this. Now, they do not phrase it the way we want them to these days. They won't say, what were the controlled variables? No. They will ask you, and I'll speak about it at the end, they will ask you, how did the investigator ensure validity? Or, yes, it's always about that. How did the investigator ensure validity? The word validity has nothing to do with anything generic in life sciences. It has everything to do with factors that are being kept the same, right? If I were to conduct my investigation, please listen to this. If I were to conduct my investigation, this one about light and plant growth, this is how I would conduct it. I would have two plants, plant A and plant B. The first plant, I would put it next to the windowsill, right? And then the second plant, I would put it inside a duck cupboard. This is me doing my investigation to determine if light is needed for plant growth or the effect of light on plant growth. This is now the statement on procedure, how I did the investigation. So I would say I've got two plants. I placed one next to the windowsill and then I placed one inside a duck cupboard. And then I measured the height of these plants every second day for about 10 days. Now, in order for my investigation to be validity, I will need to ensure that there's certain factors that are kept the same since I'm using two plants, because I want the results to be about the effect of light on plant growth. I do not want anything else to have an effect on plant growth outside of light. So that means all of those factors I need to keep the same to ensure that my investigation is valid. Now, what would I then need to keep the same here? This is a grade 8 investigation, trust me. So things like same amount of water, it would need to be the same, right? So this is how I would answer: same amount of water. Please remember, if you say same amount of water, I'll give you a mark. But if you say same water. We do not know what that is. What do you mean by same water? Same amount of water. If I give plant A 500 milliliters, I need to give plant B 500 milliliters. Now that is my validity. Both plants have received the same amount of water. At the same time, if I'm watering them at 7 a.m., I need to water plant A at 7 a.m., plant B at 7 a.m. So same time for watering the plants, amongst other things. I will just mention them, right? If I'm using these two plants, I need to make sure that both plants are the same type or same species. We're in grade 12, so we are going to use the word same species. Now, I cannot use plant A to be an amarula tree, and then plant B, I use a tomato plant. Those are two different things. They respond to water and light differently. So I need to make sure that I need to use the same family or species of the plant, right? They have to be the same height, because I said I'm going to measure the height of these plants every second day. So at the beginning of the investigation, if plant A is 12 centimeters, plant B will also need to be 12 centimeters, so that I'm able to compare the results as I keep on measuring the height. I am not mentioning other factors just because of time, right? But I hope you can see what is happening here. With the two different plants, plant A was next to the window. So that means plant A is the one that received light, right? And then plant B was in a dark cupboard. So that means plant B actually did not receive light. So I've got my two plants. I am keeping everything to be the same. The only thing that is different is the factor that I'm investigating, which is light. One is going to receive light, one will not receive light. Now, the reason for that is for me to compare the results at the end so that I can understand the effect of light on plant growth. The plant that is exposed in light or to light is expected to grow taller than the plant that is not exposed to. I'm going to use that information to conclude that since this plant that was next to the windowsill has managed to grow taller than the one that was not, that means plants need light to grow, or light causes plants to grow. Okay, so I hope you're connecting the dots here. Let me see. So far, if you have a question, feel free to answer. Wow. Feel free to ask. I'm trying to connect my laptop here. Feel free to ask. Anyone with a question, just raise your hand so that I can see. Zara, your hand is up. Is it to ask a question or you were answering one of my questions?
Ma'am, I wanted to answer the other question.
Oh, okay. Do you have any questions so far?
No, ma'am.
Okay, thank you. All right, let's move. Please feel free to raise your hand whenever you have a question, guys. Please feel free. Okay, aim, I think I've done justice. Oh, this is our other friend. Hypothesis. We have to know this. We have to. A hypothesis is more of an answer to the aim, right? And the most important thing here, when you are asked to write the hypothesis, the most important thing is the format, the way in which you answer it. It's not just about the answer, it's the way in which you answer. Now, the hypothesis must be stating the two variables and what you think will be the outcome of the investigation. In our investigation, we said to determine the effect of light on plant growth, to determine the effect of light on plant growth. And me and you have agreed that light will be the independent variable and plant growth will be the dependent variable. Your hypothesis would need to have mention of these two factors. And you are not going to say light has an effect on plant growth. What effect? What do you mean by effect? Light causes the plant to grow. So you still have spoken about growth. You still have told us something about light, but it actually can be in a negative. You can say light will not cause plant growth, because a hypothesis is normally answered or done before the official investigation. Now, what will be the expectation here? One, you will be given the aim and they may ask you to write down the hypothesis. Please take note of this. You are not discussing or explaining anything. It is a statement. Do not repeat the question and say, the hypothesis is wrong. Do not say, I think light will cause the plant to grow. I believe that photosynthesis is very, wrong, immediately, wrong. So we need to work on the format for hypothesis. Variables, I've mentioned. Variables, I've mentioned all three: independent, dependent, controlled variables. Same. Make sure that here you have everything about same. Don't say same plant, same type of plant, same species of plant, right? Based on our investigation, same type of soil. Now, the chances of you getting a plant-like investigation are very slim, especially in paper 2. Yes, you might get an investigation in paper 1, but that will be on plant hormones, not an entry-level grade 8, grade 9 investigation. So that is something different. Okay. Then apparatus. In an investigation, you will need to list all the material that you're going to use. So in my investigation, I would need to list that I'm going to use 2 plants, I'm going to use a certain type of soil, I'm going to use plant pots, I'm going to use a ruler to measure the height, I'm going to use water to water my plants. I list all of those things. The method becomes our friend. The method is our friend. When you are given an investigation, the most illegal thing you can do is to ignore the method and just go straight to questions. How? You need to know how they have done the investigation, because they are going to tell you on day 1, this is what we did. We took plant A and placed it next to the window, and then we took the second plant and placed it under the cupboard or under the table or whatever. There's so many things that you're going to get in the method, so many things to help you answer. There is what we call validity, which I have just mentioned, that validity has to do with factors that are kept the same. You're going to get it there in the method, because they will tell you that all 3 plants were watered at 5 a.m. every day. That is a validity point, because all the 3 plants were watered at the same time, because they said 5 a.m. every day, right? Same time. You're going to get that from the method. From the method, you are then going to get another one that can be a little bit confusing, which is about reliability. When they ask you how the researcher ensured reliability, there is no generic answer. There is no general knowledge or generic answer in life sciences. When they ask about reliability, they are asking about 3 possible things. When you see the word reliability, my darlings, think RSA, Republic of South Africa. Now, R stands for repeat. If you do the investigation and get certain results, if you were to repeat it again and get the very same results, we consider your investigation to be reliable. Now, if they ask you how the investigator ensured validity, you are going to check the investigation and you are going to find that in the method or the abstract, have they repeated the investigation? If they have done so, you answer, the investigation was repeated. You get a mark. Because what would have been your question there? The question would have asked, how did the investigator ensure reliability? You check, was it repeated? If it was not repeated, you can't say it was repeated while it was not, right? Because there in the abstracted method, they would have mentioned how the investigation was done. S is the sample size, right? I said Republic of South Africa. S stands for the sample size. Sample size has to do with the number of either individuals or samples or plants or animals or bacteria that were used, whatever that has been used. How many did they use? It has to do with that. Now, in order for us to consider an investigation to be reliable, we'll need the sample size to be large. I hope you'll hang out till the end so that we can at least get through some examples. Remember, I'm explaining for now, and then we'll get through some examples. Please just hang on. If you need water, just drink water. If you need an apple, just have an apple. This is going to benefit you. Okay. Now, how are you going to answer this? If they ask you, how did the investigator ensure reliability? One, you check, was it repeated? If it was, that's your answer. If it wasn't, you move. You can't force them to repeat the investigation. The next one is the sample size. Now, this is a bit tricky in life sciences, right? If the investigation, they tell you that they used 20 plants to conduct an investigation. In life sciences, that is considered a good number for you to do the investigation and conclude, right? So you would then say they used a large sample size of 20 plants. You get a mark because you are basically saying they have used a good amount of plants for them to give us this conclusion based on the investigation that they've done. They can also use 600 individuals. You will see in the investigations, they will say 600 participants or 600 volunteers. Now, that is the number of people, plants, bacteria, whatever that has been used. However, if the investigation was done and they've used 2 plants, you cannot then say they have used a large sample size. It wasn't large. They've used 2 plants. So that means you're going to eliminate that option. You can't say they've used a large sample size. Now, it becomes tricky because there is no minimum amount in life sciences for us to say, okay, if it's minimum 15, it's not considered large. If it's maximum, whatever, it's considered large. There's nothing like that. I doubt there's any teacher that has ever given you a mark because I've been marking for 10 years. Even at the marking center, they've never indicated that to us. Okay, so you just need to read into the investigation. Okay. So large sample size, you look at the number of things, participants, individuals, whatever that they've used. If you just have to trust your gut there, but I feel like, hey, I don't want to give you a number because I'll be wrong. It's fine. We'll go through the examples. And then A stands for average. Average. If they tell you something in the investigation and they say, this was then counted 3 times and then average was calculated, boom, that is a reliability. Because if you can get an average, that means you would have done something a couple of times and then received the result of data a couple of times and then you calculate an average. So average actually links with a repeating of the investigation. Now, how are you going to answer this? The question is asking, how was reliability ensured? If they don't mention anything about an average being calculated, you cannot then say an average was calculated because we are giving them something that they didn't do. But if an average was calculated, that is your answer. My thing is, students confuse the two. Cram, pass, forget if you have to. The reliability is the one that goes with RSA. And then the validity is the one that goes with same, what has been kept the same, what has been kept the same or equal in the investigation. All right, I'm going to go to Teams and check if there are hands. If you have a question, please don't say, I'm joining this lesson for the first time, blah, blah, blah. Please don't be shy. It's a big step that you managed to join. So please raise your hand. I will note it and then answer your questions. Please make sure that you benefit from this lesson. Okay, so I feel like here I have kind of mentioned everything, how to conduct, the method, the apparatus, the control variables, blah, blah, blah. Okay, I forgot one thing. Here, in the method, in that abstract, you will also get your answer here when they ask you about planning steps. When they ask you about planning steps, now, there is a way in which you need to answer this, but I'm not sure if I should mention this or later on, but it's fine. Let me mention it since I've started already. So when they ask you about planning steps, you're going to go to the method and find out how they've done the investigation. Now, this can be confusing because we accept other things and then we don't accept other things at the marking center. When we look for planning steps, I'll speak about the investigation mind, right? To determine the effect of what is it? The effect of light on plant growth. Sorry, I was thinking photosynthesis. Now, remember, if I'm doing the investigation, I would need to use plants, right? And how many plants did I use in my investigation? I used 2 plants. Now, that is actually an answer, guys. That's a planning step. Because while I was planning the investigation, I had to decide the keyword for a planning step. I had to decide on what? On the number of plants that I'm going to use. Now I'm using my example. I first had to decide on the number of plants that I'm going to use. Now, how are you getting this from the method? Because the method would have said 2 plants were used. You're using that. 2 plants, that means they had to decide on the number of plants. And then they tell you that maybe they use tomato plants. How many plants do we have in the world? Thousands of different species. So don't you think that from the 1,000 different species, or if I went to the garden and then sourced out some plants, I would have decided that for my investigation, I want to use tomato plants, not any other plant. So don't you think that's something that I had to decide on? That's a planning step. So planning step has to do with what would have been decided for the investigation. So first, I've decided on the number of plants. I also needed to decide on the type or the species of plants. This is not difficult. You are then taking what has been given in the investigation, right? So I'm using the tomato plants. And then they tell us that every second day, the plants were watered with 500 milliliters. That is a lot anyways, right? We are going to use this. Don't you think in the planning steps, I would need to decide that, okay, the plants were going to receive this amount of water. So that's me deciding. That is a planning step. The key word in planning steps, decide, 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 decide. Right? So decide on the amount of water. Now, you are not collecting this from the atmosphere. You are taking it from the investigation that you would have been given. Don't you think you need to decide on how you're going to record the results, right? So if they have given you the table, don't you think they had to decide that they're going to use the table to record the results? Yes, they had to. So decide on how to record the results. Don't you think we have to decide on the duration? If my investigation is 10 days, they would have indicated it there on the method. So I'm deciding on what? On the duration of the investigation. Tick, we just give you a tick and we're like, oh, the student knows exactly what they're saying. Now, when you think planning steps, I need my voice to ring in your brain with the word decide. If you don't have this word, I'm marking you wrong. National level. The only answer that does not have the word decide, which is considered a planning step. This is when we're like, is this really a planning step? One of the planning steps is to ask for permission, right? So if they ask you about what are some of the planning steps that the investigator would need to consider at the beginning of the investigation, one of the answers there is to ask permission. Listen to me, my people. If the investigation has to do with people, human beings, yes, you have to ask for permission, right? So you then say ask for permission, because if I want you guys to participate in some investigation, I will need to ask you for permission, right? But if an investigation, let's say they say it's at a vet's lab, don't you think I would then need to go to vets and ask for the lab manager permission to do my investigation? Yes, I would need to. So read into the investigation for you to determine who needs to be asked permission. If my investigation is on 5-year-old children, I cannot then say, ask the children for permission. That is wrong. I'm asking an underage person for permission. How does it work? It doesn't work like that. So in this case, you will then say, ask the parents. So I need us, when we are answering investigation questions, to make it feel like you are the one conducting the investigation. Do not eliminate yourself from the investigation. Be part of it. Make it feel like, okay, I'm the one doing this. Would I ask a 5-year-old for permission? No, you would not. You would ask a parent if it has something to do with permission. Okay, I'm moving. I don't see hands, that's why I'm moving. So if you have a question, please feel free to just raise your hand, and then I'll stop, and then I will answer your question. Okay. Recording results. You are going to be given the results. You will be given the results. They're not going to ask you to record. However, your job would be to analyze the results. Most of the time, your results will be given in a table. That is the most simplest form of giving results, right? You will be given the results in a table, and you just need to know how to analyze. What are some of the things we would need to analyze here? The numbers, the data that you're given. Number one, the relationship between the variables. If, for example, this is the table that you're given for results, when we did the investigation about light intensity and photo, okay, this one's going to be complicated because I'll use the distance, and I don't want to waste time explaining the distance business. Let me do the light and plant growth. Okay, time that is measured in days, and plant growth. Let's say for plant A. Plant A is the one that was next to the windowsill. I'm not going to do for both. The one that was next to the windowsill. Okay, so let's say on day 2, remember we said we are measuring the height on every second day, but it will actually need to start on day 0. Let me do the right things. I'm trying to rush, but let me do the right things. I'm starting on day 0. I hope I'm not confusing anyone. Day 0 in an investigation is the first day. So if I'm doing my investigation today on the 22nd of August, that will be considered the initial day, day 0. And then I'm going to have day 2, day 4, day 6, day 8, day 10. Remember I said the duration is 10 days. Okay. And then my plant growth, let's say on the first day of my investigation, it was 12 centimeters. There are my units there. And then it was still 12, and then it was 13 imaginary growth, 14, 15, 16 centimeters. Right? Now, they can ask you to describe the relationship here between the days and the plant growth. There is a way in which you then describe this. Please note, make a note, make a note, make a note. If a question is asking you about a relationship, 1, you need to make sure that the format of your answer is correct, right? And your format, this is how you answer it, as your independent variable, because they will tell you, give us the relationship or state the relationship between this and that. That will be in your question. You then say as the independent variable. You are substituting. I hope you understand. You're going to substitute the independent variable there, right? As this, you then tell us, is it increasing or decreases? As this increases or decreases. How are you going to decide which word you're going to use? From the table, and then comma. As time increases, time doesn't increase anyways, but I'm just making an example. As time increases, what happens to the plant growth? The plant growth also increases or decreases. I need these words, please, in your answer. Do not write anything else. In physics, when they speak about a relationship, they will speak about directly proportional, right? And then they speak about proportional and inversely proportional. Illegal words in life sciences, do not write them. Will mark you wrong. Now, you need to substitute as the independent variable. If the independent variable is light intensity, Your answer will say, as light intensity increases. How are you going to know whether it's increasing or not? You would have looked at the numbers going down. What is happening to the numbers? Are they increasing? Here, if we look at the days are increasing. Bad English, but you get what I'm saying. From day 0 to day 2, day whatever. The days are increasing. What is happening to the plant growth? The plant started at 12, then it moved to 12, 13, 14, 15, and 16. The plant growth was also increasing. So my answer, and it's normally for 2 marks, as the days go by or as the days increase, the plant growth also increases. I need the word increase. But sometimes it will be increase, decrease. Sometimes it will be decrease, increase. You are directed by your numbers. It will not always be increase. So I hope it makes sense. Directly proportional, if you had it in your mind and you were answering it, don't. Inversely proportional, we know what those two mean. Don't answer them at all. Okay? Do not mention them in your answer. I need as this happens, that does this. Another option is remain the same. So let's say, for example, this is our data, 0, 2, 4, 6, 8, 10. But the plant or the height growth remains 12. So how are we then going to describe the relationship? As the days go by, the plant growth remains the same because it had remained the same day. It is 12, 12, 12 up until day 10. So that's how you answer. Please, please, please. I'm going to go to Teams and check for hands. Okay, nothing so far. Oh my God, conclusion. This is a 2 or 0 kind of a question. When they ask you to state the conclusion, this is the star. So that means it's something you should know. When they ask you to state the conclusion, please do me a favor. Go back to the aim. Go back to the hypothesis. Go back to the results. And then you answer. Our investigation was about the effect of light on plant growth. And we did an investigation whereby we had plant A and plant B. Plant A was next to the windowsill, and plant B was inside a dark cupboard. And then we measured the height of these plants, right? We measured the heights. Let's say day 0, day 2, day 4, day 6. I'm not going to do everything. I'm just trying to explain this. And let's say this was 12 and 12. And then this one increased 12, 13, 14. This remained 12. And then they ask you to conclude. You cannot, in your conclusion, say plant A grew taller than plant B. Wrong. Now, for me and you, we can see that plant A's height has managed to grow because we started at 12 and then we had 14 centimeters, right? But with B, we started at 12 and then we ended at 12. You cannot then reference your conclusion on plant A and plant B in your answer. Your conclusion must have both the variables, and it is supposed to be answering your aim based on the results. Now, what would be your conclusion here? Remember, the aim was to determine the effect of light on plant growth. We then used plant A and B to determine that. Plant A received light and has managed to grow taller. Plant B did not receive light and it did not grow based on our results. You then conclude and say, light causes plants to grow, or light causes a plant to grow. That is your conclusion. In my conclusion, there's no reference of A and B. Those plants were used in the investigation in order for us to get an answer. We had 2 plants, one received light and one did not. The one that received light managed to grow. So I'm concluding to say, actually, light causes plant to grow. You cannot say plant A grew taller than plant B. Wrong. You are analyzing the results. We are not analyzing. We are concluding. I am moving. Okay, let me pause for a question. I'm listening. Unmute. Anyone. I'm not moving up until I get a question. That's how it works. I need to get a question and then I move. If no one asks me a question, I'm not moving. I'm listening. Based on what I've covered.
Ma'am,
Yes.
can you please repeat the conclusion? You were moving too fast for me.
Okay. Yeah, I am speaking too fast because I have so much to cover. Sorry about that. Light causes plants to grow. So in the conclusion, I then would have had both my variables. So if I say light causes or light has caused plants to grow or plant growth. Now that means in my conclusion, I have my two variables. My light is there and my plant growth is there. If you're concluding by saying plant A grew best, plant B did not grow, do we have the two factors? We don't. We don't. I need your answer to be based on this. So please make note. This does need a little bit of practice, guys. It's not a matter of after this lesson you become the skills queen or king. You kind of have to practice. We'll be able to do maybe one or two questions together and then take it from there. Okay, I think I'm speaking about graphs now. Okay, I'm moving here. Reliability.
Sorry, ma'am.
Yes, yes.
Okay, sorry, ma'am. Hey, my network is very bad. Can you please explain the hypothesis for me and the results, just briefly?
Hypothesis is a possible answer to the aim. So hypothesis is the possible answer to the aim. And sometimes the hypothesis will be very similar to the conclusion. So for example, our aim was to determine the effect of light on plant growth. So the hypothesis there would be light causes plants to grow, or light will not cause the plant to grow, or light has no effect on plant growth. And you need to be able to write it in a correct format. What else did you need me to repeat? Is it the results?
Yes.
Okay, so results are recorded in a table. You will be given the results. The only thing you need to know how to do is to analyze them. You analyze the relationship. You tell us which day yielded the highest height or whatever that you are questioned about. So it's more of analysis. At this level, they don't ask you to give results at all. It's more of analysis. Okay, so we'll be able to do examples just now.
All right.
That's why I'm rushing. Okay, thanks, Tandy. All right.
Thank you.
Planning steps. I spoke about them, guys. Planning steps, there's the words. Decide. If you have to screenshot this. I will also be uploading this recording, I think, on YouTube. If there's anything that you missed, you'll be able to catch up on it. Okay, I'm rushing to do graphs. Then there's this big boy over here. Okay, let me explain. Yes, yes.
Ma'am, will you also download or send the document to the group?
Yes, I will also send the documents. If I don't send it today, just remind me, I'll send it to you. Okay.
Okay.
All right, thank you. Then there's experiment and control. Please just be lenient with me, guys, because I'm not going to be able to provide another free lesson. So if we end up pushing it beyond 7:30, please just stick around, because then that means we'll be able to do an example or two. This at work, we cover it for 2 weeks. I'm trying to squeeze a good 16 hours lesson into 1 hour 30. So please just bear with me. Okay. And then we have what we call an experiment and a control. This is called experiment group and control group, not controlled variables. The controlled variables were those factors that we kept the same. Control group means something else. Now, in my example, I had two plants, remember? I had plant A, which was next to the window sill. And then I had plant B, which was put in a dark cupboard. when we speak about doing investigations, you will sometimes have a plant. It could be a plant, it could be an individual, it could literally be anything, right? A group, sometimes it's called a group. A group that will receive the treatment or receive the independent variable or whatever that has been tested. I'm going to ask you guys questions, right? And then in the same investigation, there could be a plant or a person or a part of a plant or a bacteria or whatever that is still part of the investigation, but does not receive what is being investigated. Our investigation said to determine the effect of light on plant growth. Okay? And then we said that light was what we wanted to investigate because we wanted to investigate the effect of light on plant growth. We said light is our independent variable and plant growth is our dependent variable. Now, from these two plants, I've got plant A, which was next to the windowsill, and plant B, which was inside a cupboard. Now, if you listen to my investigation, I said all the other factors for these two plants were kept the same. Both the plants, the one next to the windowsill and the cupboard, received the same amount of water. They were the same type, same duration of the investigation, same type of soil, same amount of soil, same everything. What is it that one light received and the other did not receive? Tell me, someone unmute. What is it? Everything else was the same, but there's only one thing that one plant received and the other plant did not receive. What is it?
Light.
Fertilizer.
Light. So the fertilizer is a different example, light. Okay, so the plant that was next to the window received light, and the plant that was inside the cupboard did not receive light. Now listen to this. The plant that received the treatment, which is what we wanted to investigate, the independent variable, plant A will then be regarded as the experiment group, because it received exactly what we wanted to investigate. It received light. And then plant B was inside a cupboard. It did not receive light. So plant B will be known as the control group. I hope it makes sense. The one that receives what we are investigating, which is light, will be known as the experiment group. And the one that is not receiving the factor, it will still receive all the others, not receiving the one that we are investigating, meaning the independent variable, that is considered the control group. Now, in the investigation here, they are in the example, they are speaking about plants being given fertilizer. So if I've got two groups of plants, maybe an X and a Y, the X plant, I'm able to give it a fertilizer. Maybe I am investigating the effect of fertilizer on plant growth. And then plant X, I give fertilizer. Plant Y, I do not give fertilizer at all. So that means plant X will be known as the experiment group because it's receiving what I'm investigating. I want to see if my plant will grow at a faster rate if I give it a fertilizer. So X will be the experiment and Y will be the control group. Now, in grade 11, there's an investigation there, right? And they sometimes bring it into matric. It won't necessarily be about two plants or two individuals or two groups. You need to read into the investigation. If, for example, they're saying they're investigating the effect of a certain hormone and the investigation was participated by 600 people, 300 of those people received the hormone, let's say hormone HH. This is my hormone and your hormone. It's not recognized in life sciences, right? And the other 300 did not receive hormone HH. Now you need to figure out between the individuals, which group is now considered the experiment, the one that received the hormone, right? And the one that did not receive the hormone, is the one that is controlled, that is known as the control group. Sometimes it can be on one thing. It doesn't have to be two groups. In grade 11, there's an investigation there, whereby the investigation is about if chlorophyll is needed. For me and you, we know that chlorophyll is a green pigment which absorbs energy from the sun, right? And then they are going to investigate here to say, we need to check if chlorophyll is needed for photosynthesis. They use one leaf, right? No two plants, no two groups, they use one leaf. Now, the leaf is known as a variegated leaf because the leaf has a green part, the one that I've highlighted green there, and then the leaf has a white part. The investigation to determine if chlorophyll is needed for photosynthesis. So chlorophyll, the green part, is the independent variable. Now I need someone to tell me between the green and the white part, which one will be the control group, which one will be, sorry, the experiment group. Litabo?
The green part will be the experiment group, then the white part will be the control group.
100%. I wanted to give you this example so that I can eliminate that storage of it has to be two plants, it has to be a group, one leaf. We're investigating if chlorophyll is needed for photosynthesis. The green part has chlorophyll. The white part does not have chlorophyll. So the white will be the control group, the green will be the experiment group. I'm moving. We analyze tables. Woo! Okay, I still have tables, I still have graphs to speak about before we even do examples. Tables are important. Tables are important. One, a table could be a table of comparison. When a question says tabulate, you need to draw a table. Now, when you draw a table, let's say it says tabulate two differences between DNA and RNA. Right? That one we know the answers to. We know the answers to. You draw a table, my people, because the table being drawn with the heading, before you even put your answers, we give you 1 mark, believe it or not. You then draw your table. I'm not going to give you the answers to this. You then draw your table with all your table lines. But whatever you draw in life sciences, it doesn't matter what you draw, but whatever that you draw, it needs to have a heading. Now, when you are given a question, tabulate two differences between DNA and RNA, that is not a brain surgery because you're going to copy that and put that as your heading. What are you going to say as your heading? A table showing, you copy from the question now, showing two differences between DNA and RNA. The teacher will then write T on the far right side of your table and give you a tick. What is this tick for? I'm seeing your table lines and I'm seeing your caption before we even look at your answers. And then you're going to say, in this column, I'm going to compare points for DNA. This would be the points for DNA. And on this column, this would be the points for RNA. In the same row we read left to right. You compare the same trait or you compare the same characteristic. If you're going to say DNA is double-stranded here, you are telling us about the strands of your molecules. So in the first row, you're speaking about the strands and you're saying DNA is double-stranded. That means the comparison for the strands in RNA would be single-stranded in the same row. You cannot say DNA is double-stranded and then on this side you say RNA has uracil. That's wrong, because on one side in the same row you're speaking about the strands and on the other side you're speaking about a base. Crash. If you want to speak about the bases, you're then going to go to the next row. You then say DNA contains thymine and RNA contains uracil. That is a comparison of a base. I'm sure you can write other comparisons. That is fine. If it's a table of data, remember this one is an answer you're writing. And please make sure that you do not give us one-word answers. Don't write thymine and uracil. We don't recognize that, right? Has thymine as one of the bases, has uracil as one of the bases. If you are in this lesson and all you are doing is to listen to me, you are not gaining anything from it. I hope you are making notes on your side. This would be 2 hours that you would have wasted if you are not making any notes. Trust me. Okay.
Yeah.
Data.
Yeah.
Yes, yes.
Are we supposed to say bases, not nitrogenous bases?
They accept both. So whether you say bases or nitrogenous bases or nitrogen bases, they'll accept.
Okay.
All right. Thank you. This is a data table. A data table will be given to you. This is important. A data table is important to you, right? Because one, you are going to analyze results given in a table. So you need to be able to analyze it. Now, whatever that is written in the first row, this is a very first column. This is a very basic table. If you've got 2 columns, we read columns top to bottom, right? This becomes your independent variable, but I have to explain, not independent variable of the investigation. This becomes information that you're going to write as your independent variable in your graph. If you are asked to draw a graph using this table, the first row will have information that you're going to write on the horizontal line of your x's. So that means the time in days will go on your x-axis, which will be your independent variable for the graph. It does not mean that's the independent variable for the investigation. Now, if you, because we see this a lot, students swap them around. So I need to have time days in the x-axis, and the second one, plant height, would need to come here. That would need to be the plant height. But please take note, you are given the units. So please don't forget to include the units. If you don't include them, you lose a mark. The plant height here is measured in centimeters, and the time is measured in days. You forget that, you lose a mark. Now, if you're one of those people who like, okay, I get the table, but then I forget which side is which and whatever. If you follow the correct order of your alphabets, X comes before Y. So that means the first column will have information that will go to the x-axis, and the second column will have information that will go to your y-axis. I'm moving because I need to speak about graphs. There they are. You've got 4 types of graphs. 4 types of graphs. 1, a bar graph. You cannot, in metric, lose marks on graphs. I am highly passionate about this. Your paper 1, I am 100% sure. I have not seen it. Your teacher has not seen it. Your HOD has not seen it. Your principal has not seen it. But I'm telling you, and I'm not even a prophet, there will be a graph there. But do I know which graph will be there? No. Do you know which graph will be there? No. So for me and you, we need to be safe and know how to draw each graph, because we do not know which one we are going to be asked to draw. A bar graph is the one that will have bars and spaces in between. I'll speak about them in detail just now. I'm hoping that by past, I'll be done explaining everything so that we can at least start doing examples. Right? A histogram is very similar to a bar graph, but this one has bars and there are no spaces in between. A line graph is very different to any other graph. It has coordinates. Here, we use line graphs when you have continuous data, and the data for both x-axis and y-axis is normally in numericals. So it will be numbers. As you can see, it's numbers this side and numbers this side. Unlike in a bar graph, if I collect data here from you guys about, sorry, my phone is ringing. Okay, about the different fruits that you guys like. So here it will be the name of fruits, and then this side will be the number of learners. Okay, so it might not necessarily be numbers all the time. It can be numbers. They can try and trick you, but the nice thing, they'll tell you draw a bar graph. So then you're gonna know bars and spaces in between, line graph coordinates. I'll speak about them in detail now. Hey, I'm gonna tell you this. Gauteng. I'm not sure about Western Cape or whatever. When you're writing your prelim, can you pack your protractor, please? Pack it, pack it, pack it. If you look at the past 4 years, and I'm going to reference Gauteng papers because I teach in Gauteng, right? There has been a pie chart in the prelim exams the past 4, if not 5 years. Carry it to be safe. Each graph that you're going to be asked will be worth 6 marks that you cannot afford to lose, right? The chances of you being asked to draw a double line are very slim, but we also have to be safe. I don't think I'll be able to do a double line and a double bar in this lesson. Okay, someone is talking. Is it a question? Okay,
Yes,
no.
ma'am. Since we were asked to draw the stick diagram and we were never taught how to draw that one, how can we draw it?
Which one, ma'am?
A stick diagram. It was, I think, question 2 in Gauteng.
Which? Do you want to send me a picture? I don't know what a stick diagram is.
I also don't know, ma'am, but we were asked to draw it.
Ma'am, she's talking about that DNA what?
Oh, okay. So that's not a graph. Okay, that is not a graph. So I will have to look at that question paper. I think that's from a mock exam. It could be. A mock exam is the one that they give to you guys in preparation for prelims. So I don't know if I'm wrong. Just tell me. Lulama?
No, it was in the June exam. Yeah, it was in the June exam.
Okay, I will have to check what that is. So, but it's definitely not a type of graph. It could be from an investigation and results of that particular investigation, or DNA. Someone mentioned about DNA. So I'll have to look into that. Okay. So let's look at the different types of graphs. And we're going to do them in detail. Okay. Bar graph. When you are asked to draw a bar graph, please take note of this. You then use your table. You have to have a ruler. Your ruler you have to have. Pencil you have to have. Pen you have to have. These two lines are your x-axis and your y-axis. I think this one we were taught in maths in grade 8. Okay? The information in your table that is in the far left about time, let's say in our example it was time in days. We are going to write it here, time in days. And then they said plant height, right? They said plant height, and they said the height was in centimeters. You are going to put that here. You are labeling to say, on this line, ma'am, I am speaking about time in days. On this vertical line, ma'am, I'm speaking about plant height in centimeters. This is important. Then comes the big problem. The time here, oh, okay, time will probably be a line graph, so I need to use a different one. So time will be a line graph. Let me use a different example because that's continuous data. Okay, so let me use a different example. Let me collect information about fruits. I think this one will be easy. Okay, so just give me a second. Let me get it right. I don't want to teach you the wrong things. Okay, so let's say I collect data from you guys about your favorite fruits, right? So this is data from grade 12 students in August 2026. I then ask you from the options that I'm giving you, which one is your favorite fruit? And then here I'm going to record the number of learners. We're going to forge this data. I then ask, okay, so how many of you guys are saying apple is your favorite fruit? Then people raise their hands and then I count 5 students. And then I ask the students, how many of you are saying orange is your fave fruit? I count and I get 6. And then I ask her, how many of you are saying banana is your favorite fruit? I love banana. So I'll probably count myself here also. And then let's say 12 students. Okay, this is our data. So the first row will have the favorite fruits. You are basically copying what is written there. Favorite fruit. Okay, and the favorite fruit doesn't have a unit, so I'm not going to write anything in brackets. And then on this side, number of the learners, number of learners. Again, number of learners, it was just counted. It was not really a measured amount. There's no unit. Now I need to use my ruler because I need to section out spaces for my bars. And I need to make sure that the space that I section out is equal for each bar. So I'm going to say, okay, in this particular space, and I'm using my ruler. If I'm saying that space, I am counting 2 centimeters. This will be my space where I will draw the bar for apple. Right? And then I need to make sure that the space between the apple bar and the orange bar is equal to the space between the orange bar and the banana bar. It's going to make sense now once I start plotting them. Okay? But I need us to work on this when it comes to our scale for our y-axis, OMG. You cannot, this is illegal. You cannot, when you are given this and say, okay, they have given us a 5, I'm going to write a 5 there, I'm going to write a 6 there, and then I'm going to write a 12. This is illegal, guys, in life sciences. You cannot. This is laziness. I think I can even, well, I know we can't do this as teachers, but even give you a 0 for everything. For that 6 months, I give you a 0 because you are showing me that you are not putting any effort. You are lazy. From the number that you are given, from the numbers that you are given on this table, you need to figure out a scale that has equal increments and equal intervals. What do we mean by that? Where both your lines meet, there is a 0, grade 8. Where your y-axis meets your x-axis, there is a 0 there. So there is a 0. Whether you're writing the 0 or not, we analyze it as a 0, right? And then when you look at the numbers that I've written here, we need the difference, the intervals between the numbers that you've written has to be equal. If we're to look at it, me and you, there's a 0 here. Between 0 and 5 is 5. Between 5 and 6 is 1. Between 6 and 12 is 6. These 3 numbers are showing us that your scale intervals or increments are not equal, because between 0 and 5, there's an increment of 5. Between 5 and 6, there's an increment of 1. Between 6 and 12, there's an increment of 6. That is incorrect. If your scale is incorrect, that means your bars will be incorrect. And that applies in a histogram also. That applies in a line graph also. Now, you need to decide. This is when you decide something in an exam without being penalized. You are going to use the numbers that you are given, 5, 6, and 12, to decide on a scale that will have equal increments. My scale might be different to yours, but the thing that needs to be the same is the increments. They all need to be equal. So I can decide to use a scale of 1. If I write 1 here, and then I write 2, I write 3, I write 4, up until 12, that would mean that my scale has equal increments. How do I check that? Between 0, remember there's a 0 there. Between 0 and 1, there's a difference of 1. Between 1 and 2, there's a difference of 1. Between 2 and 3, there's a difference of 1. Between 3 and 4, there's a difference of 1. And if I continue to do that and have 5, 6, 7, up until 12, all my increments will be the same. That means my scale will be correct. Same applies if I use a scale. Now I'm even explaining for the line and the histogram. I'm not going to explain that when I get to those types of graphs. Even if you decide to use intervals of 2, it is fine. This is your 0. So 2, 4, 6, and 8. So between 2 and 0, there's an interval of 2. 2 and 4, 2. 6 and 4, 2. 6 and 8, 2. Another thing that I'm sure you are picking up here, your first number on the scale indicates the increment. The first number is a 2. It has indicated the increment. Sorry, the first number is a 1. It indicates that the increment is 1. The first number here is a 2. It indicates that the increment is 2. If I were to have this one, tell me if my scale is correct or not. I'm just going to write 4 numbers. 1, 1.5, 2, 2.5, 3. I need answers. Unmute. I need to hear all your voices. Is my scale correct or not? Yes or no? Is it correct? Yes. Is it not correct? No.
It is correct.
It is correct.
Yeah, it's correct.
Yes, ma'am.
It is correct, ma'am.
Everyone is saying it's correct.
Yes.
Oh,
It's
man.
not
All of
correct.
you, all of you
Yeah.
are wrong.
No,
It's not correct.
I said it's not
No.
it's
correct.
not correct. Oh.
Correct. Yeah.
It's not.
No, ma'am.
It's not.
Can I get someone to explain why it's not correct? Is it Jaden?
Ma'am, why is it not correct?
Let's get someone to
Yes,
explain, guys. It's my scale is not correct. Someone, is it Asisipho speaking or Jaden? I can't hear, or Asisipho? Anyone speak, guys? We're
I think
running out of
like
time. Asisipho, yes,
ma'am,
I'm listening.
If I
Ma'am,
think if it was correct, it was supposed to start from 0.5, then 1, 1.5, then 2, 2.5, then 3. It's gonna be a difference of 1 interval. But now from 1 to 1.5, the distance
100%.
from 0 to 1.
Thank you very
I'm not
much.
quite sure, ma'am.
My scale is incorrect. Exactly what Lungile is saying. Because let's check here, guys. Let's start. Remember, there's a 0. So the difference between 0 and 1, what is the difference? It's 1. And then the difference between 1 and 1.5, it's 0.5 already. I do not have to go further because there's 2 different intervals there. If I continue going up, yes, it will be consistent and be 0.5 for all. But the first one is incorrect. My interval there was 1. So my scale is incorrect. If my scale were to be correct, I would need to have started it at 0.5. Then all the increments would be 0.5. Take note of that. Now, believe it or not, teachers will check your scale. I'm going to speak about Gauteng numbers. There's normally plus minus 75,000 students doing life sciences in Gauteng only. Each and every teacher will check your scale. Now, it's not only about the intervals and the scales there, it also is about the physical spaces between. So what do I mean? So this 1, 2, 3, 4. The intervals, it's 1 for all of them. But wrong. You lose the mark on scale. Why? Why are you losing a mark on scale there? It is because the physical space between the 0 and 1 is not equal. So this space that you've left here is way larger than this space. And it's obviously these two look almost the same, but this one is a giveaway that is larger compared to this one. Not the same, you lose the scale mark. So you are allowed to use your book lines. Remember, your book lines look like this, and they are obviously equal spaces. So you are allowed to use your book lines and just write a dot and say 1, 2, 3, 4, whatever. Please also note your bars. You are now plotting. Let's do this one. I'm running out of space and time. Let's say I'm using intervals of 2 here. 2, 4, 6, 8, 10, 12. Remember, I'm not using a ruler. You would be. And then you draw your bars, right? Use a ruler. Do not be lazy. If you don't have a ruler and you don't want to buy it, borrow from a grade 8 learner, grade 9 who's not writing maths or whatever on that day, and just carry a ruler. It's simple. Okay? April, we said there were 5 students. You then use a ruler and then you draw your bar. It should end at 5, not at almost 5 or 4.5 or whatever, at 5. If it's not ending at 5, wrong. Every teacher in the marking center is holding a ruler to measure your bar. So don't say they won't measure mine. They will measure it. Okay? So it needs to end at 5. Now, in our scale, where is 5? 5 will be here. Yes, you have 4 and 6. You do not have 5 physically, but we know we can read 5 in between there. So 5 will end here, and then you draw your bar in the space that you would have left. Then you do for orange. Orange, there were 6. Do the same thing. There is 6, and it has to be neat. I'm going to highlight something just now. It has to be neat. And then banana, 12. 12 there is 12 there. Not below 12, not above 12, at 12. You cannot criticize mine because I'm not using a ruler. Listen to this, guys. Your bar width, the thickness or the size of your bars, they all need to be equal. What I've done is illegal because I'm not using a ruler. So the teacher is going to mark the width, or rather not mark, measure the width of that bar. If I get 2 centimeters for your apple bar, I need to get 2 centimeters for your orange bar. I need to get 2 centimeters for your banana bar. If I don't, you lose a mark. So when you draw your bars, and this applies to both a histogram and a bar graph, make sure that your bar sizes are the same. The teachers do have rulers to measure this. That is one. The spaces in between the bars should also be equal. Now, it doesn't mean the size of the bar and the spaces need to be the same. No, no, no. If your bar width is 2 centimeters, all of them have to be 2 centimeters. Your spaces do not have to. If you decide that your spaces are 0.5, you can have their own size, but it needs to be equal across all the spaces. I'm going to say the space for a bar graph between a y-axis and the first bar, it's not considered, it's not measured. It doesn't have to be. But let's practice that you just measure it to be the same, just to play it safe, but you're not going to be penalized. Your bar needs to have a heading. If it doesn't have a heading, you're going to lose a mark. A bar graph showing whatever you are writing in your label, please make sure that the information that you have on your x-axis and your y-axis is in your caption. And this is easy. A bar graph showing favorite fruits of different students or learners' favorite fruits. Yes, a bar graph showing learners' favorite fruits. You have that. But something else that is important. If you are given any extra information that is specific to the data, you include it. A bar graph showing learners' favorite fruits. But which learners? These are grade 12 learners. They are not grade 1. So grade 12's favorite fruits they've given you a month. They've given you a year. This data was collected in August 2026. It was not collected in Jan 1995. If you have the information in your heading, but you do not have grade 12, you do not have August, you do not have 2026, wrong. Any extra information, if it was an investigation about tomato plants, right? Tomato plants in an investigation that was done over 7 days. I need the 7 days in there in your heading. I need the type of plant, tomato plant in there for you to get a mark. There's so many things I can speak about. Ooh, time. That was a bar graph. You have all of this information in the document. Histogram. Everything I've said about a bar graph applies to a histogram. The only difference in a histogram is that the bars will touch each other. It will still have a heading. You still label. The only difference is that the bars touch each other, but the bar width will also need to be the same. We measure it, and then you'll have your scale, which you would have done properly also. I forgot to mention, this is illegal. You cannot have your 0 anywhere. If you have 0 here, 1, 2, 3, this is wrong. Your 0 is where both your x's meet. Your 0 is where both your x's meet, not anywhere else. This is 100% wrong. Line graph. Coordinates. You are given data. Let's say this data is about time, and this time is in hours, and plant growth. I'm just forging something now because of time. Plant growth in centimeters. And then 1, there's so much I can say here. 2, 3, 4, 5, 10, 15, 20. Line graph. You have your time in hours. And then you have your plant growth in centimeters. This one is easy because time 1, 2, 3, 4, and then here plant growth. These are equal intervals. So 5, 10, 15, 20. This is a copy and paste. I am plotting coordinates here. At 1 hour, the plant growth for this particular tomato plant was at 5 centimeters. So there is my 1. I pull it up, and then there is my 5. Where they both meet, I draw a dot, a small dot, not this one. These dots, illegal. A small, tiny one. Okay? And then at 2, it was 10. At 3, it was 15. At 4, it was 20. Now, my example is very basic. Do not rearrange the data for your line graph to look a certain way. Follow the data as is. Go with 1 and 5 first, and then 2 at that. That's it. Even if the shape comes out something like that, it doesn't matter. You then join your points using a freehand. You don't use a ruler to join them. And you join them neatly, please. If you don't join them neatly, you're going to lose a mark. Then you have a heading. A line graph showing plant growth. If they told you it's a tomato plant, of a tomato plant, how many hours? 4 hours. Over 4 hours. If you don't have 4 hours in your answer, wrong. If you don't have tomato plant in your answer, wrong. Now, I'm going to say something. If, for example, I'm going to use a different color here. If the time was 0 and the plant growth height was 5, this is important. If the time was 0 and the plant growth height was 5, okay, I'm answering something that I know other people are already thinking about. Ma'am, do we join this to the origin? No, if you join it, I penalize you. There is no data at the origin. Our data from the initial table started at 1 hour with 5 centimeters. That's where your graph starts. That's it. You do not drag it to the origin here at 0, 0. No, that's wrong. Unless there is data that is given, right? So in the second example where I'm using a purple, the time is 0. 0 is here. And the plant growth height is 5. So that means my graph would start here. This is where my first dot would be. And then I join, right? I'm going to use a different color. My different color now is for blue. If the first time for blue was 5 hours and the growth was 0, I need you to see what is happening here. The first one for purple was time was 0 and the growth was 5. Now I'm saying the time is 5 hours and the plant growth is 0. So where would the dot be? Where is 5 hours? Okay, let me do 4 because I've got 4 hours as the last one. 4 hours and 0. So there is 4. Where is 0? The 0 is there. So that means the dot will be here. I'm going to use a different color. If they give us information and then they say the time is 0 and the plant growth is 0, where is my dot? My dot is there. You look at the data that you are given. You do not forge data. I'm going to skip double line graph and a double bar. I do not have time for it. Yeah, again, I'm squeezing an 8-hour lesson into 2 hours. Pie charts. I'm going to say play it safe with the prelims and carry your pie chart. Borrow it from someone, borrow it from a teacher. Just play it safe. If it's not there, if the pie chart is not there, it's fine. Borrow a protractor just to be safe. What are we doing here? You will be given data. And normally this data is in percentages. Sometimes it's not. You need to follow specific steps when you are drawing a pie chart. Please make a note. A pie chart will also be 6 marks. If you are given a table, I'm going to forge a very simple table, right? Because of time. I'm going to forge a very simple table and say, okay, let's say this table is still speaking about favorite fruits and the number of learners, right? So we had learners who said orange is their favorite ones. Let's say 5. I'm not going to remember the correct one. And then 5 and maybe 12 here. Let's say this is banana. And then what was the other one? Orange, banana. I don't remember another one. My brain is freezing. I don't remember. Anyone, give me the name of the fruit. Let's say peach. Okay. All right. This is your data. The question is going to say, draw a pie chart to represent the data that is given in the table. There's 3 things. Step 1, you are going to get the total. Step 1, you get the total of the information that you are given. Whether it's number of people, number of learners, number of plants, or whatever. These numbers here, you are going to add all of them to get a total. So if we add them, tell me if I'm wrong. I'll have to use my phone or tell me the total because I'm not teaching math, so I don't know the total. 12 plus 5, that's 17, plus 6, 11. Is that 23? Yes, no?
Yes.
Okay, thank you. We get a total 23. That is step number 1. Get a total of whatever you are given. If it's in percentages, it will already be in 100, but confirm. That's the first thing. Step number 2, you are then going to do calculations. What are these calculations for? Remember when you draw a pie chart, you are basically going to draw a circle which will be measured out of 360 degrees. You need to be able to calculate for each category. The categories in our example is about different types of fruit. You then need to know, okay, for the orange, what portion of 360 will the orange get? You then do the calculation for that. What portion will the banana get from the 360 based on the number of learners? We have said that banana, orange, or peach is their favorite fruit. Please make sure to include your calculations in your answer sheet. Please make sure to include your calculations in your answer sheet. Pie chart calculations, 2 marks. If you don't include them, you work them out in your question paper, you are losing 2 marks. How are you then going to do these calculations? You are going to say, okay, the first one, I need to know the degrees portion for the first category, which is orange. You are going to write it down. You are basically telling the teacher, ma'am, sir, this is the portion that I'm calculating for orange. How many students said that love oranges? There's 5 of them. Out of how many students in total? We have calculated the total already. Out of 23 students, right? And then you're going to multiply because you're saying there's 5 out of 23 students. I need to know what portion they will get from the 360. I do not have a calculator with me. I'm not sure if you guys can quickly do it. And then just unmute and tell me the answer so that at least we can continue, right? So I don't know the answer. Your answer will be in degrees and not degrees Celsius. Please do it. There's 40 something of you guys. I'm sure someone can do it and give me the answer.
It's 78,26.
78,26.
8,26.
There you go. Very important. In life sciences, your answers, round them off to 2 decimal places. But I think this one was already on 2 decimal places. If it was not, you would need to round it off to 2 decimal places. Okay. And then you say, okay, from the 360, this is you saying the orange portion is 78.226 degrees. You are not done. You do for banana. For banana, you do the same. Banana, there's 5 students. I think this will be the same thing, right? 5 out of the 23 students. Now I need to know their portion from the 360. It should be 78.26 also. And then you say, this one is for peach. You are telling the teacher who's going to be marking your paper. And then you're saying, for students, there's 12 students who said peach is their favorite fruit. Out of the 23 students, now I need to know the portion of that in 360 degrees. I'm listening. Answer?
It's 187,83 degrees.
Thank you. Now, our category was just 3 oranges. Wow, oranges, 3 different types of fruit. Now, remember our portion, our full portion is 360. To double check that we have done everything accurately, you would need to then take each degrees portion and add it together. When you add these 3, you must get 360. If you don't, that means you've done something wrong. Right? This is for you to check if you've done something right. You do not have to edit on your question paper, on your answer sheet here. You can do it on the question paper and then you double check. Now you have to now draw your pie chart. Remember I said there's 3 things. 1, you get the total, 2 calculations, 3, you draw your pie chart. Now your pie chart doesn't have commas. It will have from 0 degrees up until 180. It will be the half of the 360. You then, in your mind or in a pencil, round off any degrees that has a decimal. So 78,26, it will be 78 still because the 2 is below 5. Anyways, even if you round this one, it becomes 3, it still becomes below 5. So this would be 78. So that means on your protractor, you're going to be looking for 78. Same applies here. This would be 78. But what about this one? We need to round it off to a whole number. So then this one becomes 188 for the drawing. Do not round off the answer when you are writing it. For the drawing, you round it off for yourself. You then use a pie, what you call this, a protractor. If you do not know how to use a protractor, there is 1 and 2 minutes videos on YouTube, which you can watch. You spend 30 minutes or 2 hours on TikTok. So I'm very sure that you can spend 2 minutes on YouTube watching a video on how to use a protractor. Yes, I can see the reactions of people laughing. Yes, you do spend 2 hours on TikTok. So you can spend 2 minutes watching a video on how to use a protractor. The protractor is half of the 360. You first need to then draw the circle, right? You have to figure out how to draw it. You put it on one side and then draw the first curve and then you turn it around, you draw the other curve. There's something else I forgot, whatever that you get on that instrument box, you can also use that, it is allowed, okay? And then you need to have your dot in the middle at the center. This is what you get from your 2 minutes video. And then you now need to draw sections for each. Remember, you've done the calculations that, okay, this particular category is going to get this particular portion. The orange is getting 78. It doesn't matter which one you start which here, with which, because you're going to indicate it to us. You then say 78 is the orange one. You use your projector to measure. Your 78 should be somewhere here. You then say, okay, this is where my 0 is. From the 2 minutes video, you'll get all of this, what I'm doing. Okay, so this would be your projector, this would be your 0, and then you look for your 78, you then write a dot, and then you connect the 2 lines. Okay, you do not have to color the portions, do not color them. What I'm also trying to say here, because I said it in the May group, and they said, ma'am, we thought this was right. Your Zambak doesn't work. The mere fact that your Zambak will have a perfect circle doesn't mean it will work. Your VIX will not work. Whatever will not work. We need a protector. Please take note. Then you can then indicate a key. This will be your key. You do not have to indicate a key on the other side. You can even indicate it on the, let me actually do that. You can even indicate it on the pie chart itself and say, okay, ma'am, this portion here is for orange. This is enough. And then you draw another one. That means you need to move your projector around the 2 minutes video. You move it around and then you get another 78 and you say this one is for banana. And then this one will be for a peach. The remaining one should be the 188. You then have the heading, a pie chart showing favorite fruits of learners or learners' favorite fruits, grade 12 learners' favorite fruits of August 2026. How do we mark? There's a code, THCP. T, the question asked you for a pie chart. If you draw a pie chart and the sections, I give you a mark. H is for the heading. I'm seeing learners' favorite fruits, August 2026, matric or grade 12. I give you a mark. This C is for calculation. I go to your calculations and I check if they're correct. I give you 2 marks. The P is for plotting. I take my protractor and then I measure all your different sections. I measure them. If it takes me 5 days, it takes me 5 days. I will measure. 2 minutes video, right? Okay, and then you get your 2 marks. The total is 6. But can you see that if you did not include your calculations, you will be losing the 2 marks. And for each calculation, indicate this calculation, ma'am, is for the orange. This calculation, ma'am, is for the banana. This calculation is for the peach. I'm not saying you're going to get favorite fruits examples in your test. You can do this, write the names inside. If you don't want to write the names inside, you have a key. You can have a key and say, the one that has diagonal lines is the peach. Then you do a box and say diagonal lines, that is a peach. And then the one that has circles inside, that is a banana, circles inside, that is a banana. You do not have to write any percentages inside. Do not calculate any percentages at all. I forgot to mention. You cannot say 5 over 23 multiplied by 100. Wrong, 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 wrong. I need to project an example of a question from a previous paper. I think I've kind of covered everything. I am not covering the double line and the double bar. Questions? Questions or a comment while I share a different document? Don't be too quiet, please. I'm projecting something else. Wow, 2 hours in it. This clearly is a passion. Let's see, I'm trying to do one example. This one is easy. Just give me a second. I'm projecting something now. No. Okay, let's do this one. I'm going back to Teams. It's difficult to get students to concentrate for 2 hours, eh? It's very difficult. Okay, just give me a second. No. Okay, wait, it's projecting the wrong document. Just give me a second. Hello, Carabello. Your mic is on. Okay, cool. Give me a second, guys. There you go. 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 Okay, let's do this together. Let us do this together. I will do maybe 3 examples. This is a grade 10 example. And then I'm going to move to 2 grade 12 examples so that we can do them together. 2 hours, 15 minutes in it. Okay. Just a reaction, a thumbs up if you can see this document. It's a different one to the one that I had projected. It is, okay, happy. Okay, cool. I will do this one with you, but please, in your mind, try and find answers also. So, a fitness trainer organized a 30-day boot camp for 35 university students who wanted to lose weight. Each participant's weight was recorded on the first day of camp, and every day and every second day at 7 a.m. This information is not given to you for fun. This information is given to you for a reason. The duration of the boot camp, 30 days. How many students? 35. What did they want to do? They wanted to lose weight. Each participant's weight was recorded for the first day of camp. The first day of the boot camp was the day where they recorded their weight. And then every second day, what time? At 7 a.m. During the boot camp, participants followed a healthy diet and took part in various physical activities, including running, functional training, strength exercises. After 30 days, the trainer grouped the students according to their final weight ranges as shown below. So what did the trainer do here? So at the end of the investigation, after 30 days, they measured all the students. This is actually wrong because a weight is not measured in kgs. Those who do physics will rectify. It's actually measured in newtons. So this should be a mass instead, actually, but it doesn't matter. Okay, so then the trainer said, okay, all of those that had now measured between 70 and 80, there were 11 participants. All right, those between 81 and 90, there were 12, blah, blah, blah. How many students took part in the boot camp? They told us 35. Suggest one factor. Now, this is where you are answering. Suggest one factor that was kept the same for all participants to make the investigation valid. Validity. What was kept the same? Unmute and tell me. Anyone. Anything that comes to mind that was kept the same.
Healthy diet.
They follow the healthy diet.
Lovely. Healthy diet. That's the first one. They all followed a healthy diet. That's the first one. The second one. Oh, only the healthy diet is the obvious one. What about the activities?
Various physical, just mentioned.
The activities were the same. They were involved in same activities, not just one, because this could be confusing to say, okay, it's actually not the same. It's different activities, ma'am. Yes, they were different, but all of them were following the same different activities. I'm not sure if it makes sense. There was no one doing a marathon and then another one running. So they all took part in various physical activities, including those ones that were mentioned there. What about the duration of the camp? Wasn't it the same? It was the same. Because there were no 5 students who only participated for 20 days and 5 students who participated for 15 days. All of them, this is what was kept the same. The duration of the camp was the same, 30 days. What about recording the results? Didn't they give us the time for recording the results? They did. They said here, the weight was recorded on the first day of camp and again every second day at 7 a.m. So the time for recording the weight or the mass or whatever was the same. They did not record Tandi's weight at 7 a.m. and Jaden's weight at 7 p.m.? No. So that was the same. So we need to read into these things. Then the other question is asking you to draw a histogram. I'm not going to draw it because of time. But so you know, the weight range will come here. Weight range and the units. Number of participants will come here. And then your bars will touch each other. And then you have a heading. I want a grade 12 investigation. There is an example for pie charts. I'm just scrolling down. Ah, there it is. Believe it or not, this is from a national paper. Okay, let's do it together. I love this. I think I'm going to give you guys time. This will be the last thing we do, unless you guys opt for one more, right? This is from a national paper. I think it's 2024. Let's do it. Now you can see it's a proper investigation, right? The relationship between blood groups and risk to specific diseases has been a subject of scientific research for many years. A group of researchers have a highlighter in the exam, if it's allowed. I know in other papers, they do not allow a highlighter, whatever. If they don't allow a highlighter, have a pencil. Have a different color pen, carry a blue and a green or whatever. In your investigation, I need you to highlight the aim. When you get confused about the investigation, go back to the aim. A group of researchers investigated, this is the aim. The relationship investigated, that's your aim, investigated the relationship between different blood groups and the risk to specific diseases like cancer, infections, diabetes, cardiovascular disease. Sometimes you have to read the aim 3 times just to understand. They investigated the relationship between different blood groups. Remember, with blood groups, you have blood group A, B, and O. You've done genetics already, so you would know this. The relationship between the blood groups and the risk of specific diseases such as cancer, infections, diabetes, and cardiovascular disease. Cardiovascular disease are those related to the heart. Remember when I covered the method, I said how they conduct the investigation is very important because you're going to have points there. They tell you the investigation was conducted as follows. A random group of how many individuals? 500 individuals. Between the ages of 20 and 50 was selected. Already I've got 2 points here. I've got a sample, I've got a planning step. Blood groups AB of all participants was recorded. Scientists also recorded the occurrence of cancer, infections, diabetes, and cardiovascular in the 500 participants. So what did they do? They first recorded their blood groups, all 500 of them, to say, there is individual 1. What blood group are you? A, U, B, A, whatever. It doesn't matter. And then they asked each individual the occurrence of the cancer, or they would have checked, right? To say, okay, this individual, Asi is blood group O. Does she have an infection? Does she have cancer? Does she have diabetes? Does she have a cardiovascular disease? That's how they did it. The percentage of participants within each group who have a specific disease was calculated and recorded. After they've collected the data to say, okay, for all 500 individuals, we now know your blood groups. And for each person, we're able to record, okay, this person has received an infection, they are blood group A, they've received an infection, they also have cancer, or blood group B. This one doesn't have infection, but they have a cardiovascular disease, or they have whatever. They recorded that. The table below shows the results at the end of the investigation of the relationship between the different blood groups and the risk to specific diseases. So this is what they have. Blood group A, from the 500 individuals who were blood group A, they found that 30% of them had the cardiovascular disease, not the 500, only those who were blood group A. And for the diabetes, it was 20%, infections, 15%, cancer, 10%. You do the same for the other groups. Ah, my people. The first question, it says, state the aim. We have done the aim together. Can someone give me the aim? And I don't want just one person speaking. I think Muhao has been speaking a lot. Okay? So I don't want just one person to speak. There's quite a few of you guys, still 34. Okay? Can someone just give me the aim? I'm going to scroll up so that they can, okay, but I've highlighted it. So how would you then write the aim? To investigate. That's how you start your answer. To investigate the relationship between different blood groups and risk to specific diseases like cancer, infections, diabetes, and cardiovascular disease. That whole thing, you copied and pasted it. How many marks do you have? 2. They asked for the aim, guys. Aim, 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 aim. There it is. The format of the aim, do not write the aim of the investigation. No. Start your aim by saying to investigate, and then you copy everything that has been written there. You get your 2 marks there. Sorry, this is the aim. It goes up there. Okay? So very important. Look at what this question is asking us, the next one. State 2 planning steps that were considered before conducting this investigation. This is not a generic answer. I need you to give me the planning steps. This is what I'm showing you.
The first one.
Yeah?
I was going to say the first one, they asked permission from those 500 participants.
100%. 1 mark. Because they used individuals, they used human beings, and they told you the age, 20 to 50. So these are adults. So ask permission from the 500 individuals. 1 mark. I need someone else.
And the instead is to decide the range of the individuals who are going to be included in the investigation.
You are faint, Anita. They need to decide on?
On the range of the age of the individuals.
I think you're saying age.
Yes, the range of the age.
Correct. The range of the age. 100% correct. They needed to decide. So your answer, decide on the age range, because they did not use 20-year-olds and they did not use 50-year-olds. They said between the ages of 20 and 50. So the answer here will say decide on the age range. Love it. And then we've already spoken about the asking permission. What else do we need to decide on?
They decided on the diseases that they were going to be investigating.
Lovely. They decide on the specific diseases to investigate: cancer, infections, diabetes, cardiovascular. They could have decided to investigate on stroke, on flu, on HIV, and blah, blah, blah. The specific diseases, they had to decide on that. That's a mark. What about the number of individuals? What about 500? Isn't that an answer? Yes, it is. Decide.
And another one.
Yes.
And another one, ma'am, to decide on the size of the sample of the blood drawn on the individuals.
Decide on the sample.
Blood samples, like the size. I'm trying to figure out the English to explain. I don't think that would be correct, because they are not giving us any information about saying the blood group A people were how many. Because remember, this was a random. They just took 500 people. And then they did not necessarily decide on to say, we are going to use
from the 500, we'll use 20 people who are blood group A or 20 who are blood group B. Remember, they're taking their random. If they take me, they do not know what blood type I am. So I could be any of the blood type. So that specific one, I do not think it would be correct for this investigation. If they had said anything about the gender, our answer would also be gender. I'm just mentioning things that are just coming to mind now. 500. Yes, yes.
Ma'am,
What was she asking that you're saying it's wrong? She kind of cut off.
The sample of each blood group. Decide on the sample for each blood group. So I'm not sure if, let me see, I think it was Lungile. Lungile, are you saying that based on the table?
Yes.
Okay. But me and you, if we read the heading of the table, just to support what I'm saying, the table shows the results at the end. Remember, the planning step, the deciding planning step, we do it where? At the beginning. So these are the results from the random selection. So there was definitely nothing about sampling A only or B or A, B or O. Definitely, definitely. So that one for sampling specific blood group, no, that would not be correct. Okay. I'm trying to think of any other point. Unless you can see it, I can't see it. You can highlight it, yes?
Ma'am, would it be correct if we say that they decided on the measuring tool which they would use, because they said that they used the percentage of participants within each blood group?
Oh, I get your answer, but it's not a measuring tool. It's not a measuring tool, but how to I get it, it's correct, but it's not a measuring tool. Decide on how to maybe record the results. Yes, that would be a mark. Decide on how to record the results, not a measuring tool. I'm sure we can substitute that, but that specific word. Measuring tool is something that they would need to use to measure physically. How do they get the blood groups? So they say they recorded the occurrence. There was record, so they are not even telling us. The blood group of all participants was recorded. To get your blood group, they would need to test your blood. I think, yes, I am sure. The measuring tool, no, but I get the idea. If you say decide on how the results would be recorded, they'll actually give you a mark for that. But measuring tool, it depends on which teacher. Yes, yes, I'm listening. There's two people.
Okay, I was going to ask. Oh, are you done answering her?
Let's see. Ralikwa, are you fine?
Yes, ma'am.
Okay, thank you. Yes, Mohau?
Oh, I was going to ask, since they're going, I was going to ask, won't they also need permission from the lab?
So for me and you, that would also be correct, right? Because if you're doing this investigation, you'd need permission from the individuals, and obviously they would mark you wrong. And I'll tell you why. As much as this is correct, you would then need permission from the individuals. But remember, if I'm doing the investigation, I might not necessarily be the one taking the blood samples because I'm not qualified to do that. So as much as I'm getting the people involved, I would need the lab specialist to be the one doing all of this. So yes, I would need the permission or ask them to be on board. But according to life sciences, they might not recognize that as an answer. I hope it kind of makes sense. Sometimes things are right, but in life sciences, they are not right. Okay, unfortunately. Okay, I'm gonna move 2 hours 30. That's why people are leaving the lesson. State one way in which the researchers ensured reliability. Give me an answer. Reliability, we look at RSA. Let me move up. Maybe you need to read again.
They use the large sample size.
The sample size.
Of how many? You can't just say use the large sample size. That is correct. Of how many individuals?
500 individual was.
Thank you. That's a mark. If you just say they use the large sample size, there's no mark. Tell us, they use a large sample size of 500 individuals. 100% correct. Can we say anything about repeating the investigation? No. They didn't
No.
repeat it. They didn't tell us.
No.
They didn't tell us
No,
that
no,
they
no.
repeated it. Can we say anything about an average? No. So the only one applicable here is the sample size. Ooh, okay. I guess we can't go beyond this because of time. But can I just highlight a few things just to show you the repetition of these things? From the investigation, you are asked the dependent variable. I'm going to send you this document. If I don't, this document is for free. You'll receive it for free. If I don't, just say, ma'am, investigation document, and then I'll send it to you. The aim there. Why can this investigation be regarded as reliable? Reliability, RSA, you're going to read up here. Why would it be considered reliable? This one is easy because already you can see that there were 200 participants. They used the large sample size of 200 participants. Okay, and then I think explain why 50 participants, then you need to read into the investigation. The same investigation is asking you to list 3 ways on how the validity of the investigation could be ensured. Okay, this I did not explain in detail. When they ask you about reliability or validity, there's 2 ways of asking it. They can ask you to suggest. This is asking you to suggest. So you need to read into the investigation and tell us what they need to keep the same. Or they ask you, how was it ensured? How was it ensured? Meaning it's mentioned already. It's something that has to be mentioned already. Could be ensured, you are suggesting. I spoke about a conclusion, how to write a conclusion. This one, double bar graph. You'll have to read the notes. Let's see. There's another one that I want. This is November 2025, actually. This one that I'm passing, there's one that I want. If we look here, it is the same things that I've been mentioning. Identify the aim, identify the independent variable, identify one control variable. There's a specific there you go. Identify the relationship. Remember, I spoke about how we answer a relationship as this, and they tell you relationship between age and hearing ability. Age will be your independent variable. Hearing ability will be your dependent variable. So as age increases, what happens to the hearing ability? Where are you going to get your answer? There is your table. You read and analyze that. Okay? List 2 ways how reliable results were obtained. Reliability, RSA. You look at those 3 things. The next one is asking you to draw a line graph. Okay. I know you want to leave. And I also want to leave because it's 2 hours, 30 minutes. But this, please do this investigation. 600. That is a reliability. That's a sample size. Male volunteers. That's a validity because they use the same gender. So when you see a validity question, you can't say, no, I don't know. They've said they've used male only. They've used the same gender. That's a validity there. Each volunteer was given 500 milligrams of a contraceptive pill. They've used 600 males. All of them were given a contraceptive pill. What was the amount of that pill? 500 milligrams. That's a validity. Same amount of the contraceptive pill. What are they asking you? Dependent variable. Factors which were kept the same. Reliability. I think others you just have to read. I'm done, guys. I will send you this document. If you don't receive it, just send me a message and say investigation questions or whatever, and then I'll say